Hey, this is Dr. Vermilio, and this is part two of our lecture on research studies using the hearing and noise test. Well, this is an interesting one. Let's take a look at this. Musicians and non-musicians, pure tone average, and hint scores. The y-axis represents the binaural pure tone average, and the x-axis represents the hint composite score. So a -10 binaural pure tone average, I believe we're using 500, 1000, and 2000 hertz, and that average would represent very good pure tone thresholds. A 50, on the other hand, 50 dB binaural pure tone average would represent very poor pure tone thresholds. And then the hint composite score, recall that a -10 is a very good score, and a +5 is a very poor score. This is the range of norms for the binaural pure tone average from the 5th percentile through the 95th percentile. So we're going to call any data that appear, any datum that appear in that shaded region, we're going to call that within normal limits for pure tones, thresholds. This is the range of normal for the hint composite score. The dashed line would represent the 50th percentile. Off to the right would be the 5th percentile. Off to the left would be the 95th percentile. So anything on this side of the shaded region for the hint norms would represent speech recognition and noise ability below normal limits. Here's a group of individuals who are non-musicians, and we can see that a number of them performed within normal limits for speech recognition and noise ability. All of them had normal audiograms. However, a large group performed below average, even though they're within normal limits, and 3 subjects here performed below normal limits for the hearing and noise test, below the 5th percentile, though their audiograms were still within normal limits. Now let's look at some musicians. This is a keyboard player, a percussionist, a saxophone, clarinetist, an audio engineer, an acoustic guitarist. Here's a trombonist. The trombonist was kind of interesting. I asked him, how is your hearing and noise ability? How's your ability to recognize speech and background noise? And he told me, I don't know. and it's interesting because the score is almost exactly on, dead on the 50th percentile. Let's see, here's somebody who plays reeds, who gigs quite a bit. Clarinet, soprano sax, alto sax, tenor sax. Here's a keyboard player, and here's a string instrument. Now what about really loud drummers? Well, here, this is a fusion drummer, so he's playing in a loud jazz, rock, fusion, funk band. And here's a guy who's toured with many famous heavy metal bands. Look at these scores. So we see that there are musicians who scored within normal limits for the hint, and but it's on the, actually look at all the musicians except for maybe the trombonist, everybody, and the audio engineer, all scored below average. Several musicians were still within normal limits, even though they were below average. And then we have 3 musicians below average, but still with normal audiograms. And then we get into instrumentalists that are exposed to extremely high levels of sound. And so definitely they experience some damage in the cochlea, in the hair cell structures, and their hearing and noise ability is very, very poor. Remember the last set of graphs, very poor score was a -4, which would be over here. And look at this score is over here. It's about a +4.5 dB signal to noise ratio. So that means that this person can hear half of the sentences when the speech is about 4.5 dB above the noise. Okay, so there's our survey of speech recognition and noise ability and audiograms for musicians and non-musicians. Let's look at audiograms and hint results for 25 participants at the Audio Engineers Society Conference from 2006 and the National Association of Music Merchants Show in 2007. And we see an interesting picture here. Same type of graph. Hint composite score, poor performance, good performance. Here's the norms, 95th percentile, 5th percentile. And look at this, most of the data are actually below normal limits for the folks attending these professional conferences, audio engineers, and the National Association of Music Merchants. Very, very interesting. Very, very poor speech recognition and noise ability. And then you have a very large group here, all with normal audiograms, but most of them have speech recognition and noise ability below normal limits. We also looked at a study in 2011, presented at, we presented this at the ASHA conference in San Diego, 2011. We're looking at the effect of language experience on the ability to recognize speech and noise. This was collected in our auditory research lab at CSUN. So we looked at the effect of native language experience on speech recognition and noise ability. And we evaluated this for 21 participants with normal pure tone thresholds. The participants were divided into two groups. 11 were in the American English only group, and 10 were native speakers of Spanish who also speak English as a second language. So we're looking at the effect of language experience. Now the thinking here was that perhaps if we analyze speech production relative to a standard American dialect, so if you looked at the speech errors, would there be a relationship between the speech errors and one's ability to recognize speech and noise? So somebody who has highly accented speech, would they have poorer speech recognition and noise ability for a second language, English, than somebody who was a native American? And here are our data. This is the y-axis represents the number of speech errors. These data, the values here are from a speech error analysis conducted by Dr. P.J. Seymour at Cal State Northridge. So she took a speech sample, analyzed their speech errors, and then this is the American English Hint composite score. Very good score, very poor score. We looked at American English only, one group with American English only speakers, and a second group with who had English as a second language. These were all native Spanish speakers. And look at the data. This is the 5th percentile for the hint norms. This is the 50th percentile. And almost all, about 80%, so 8 out of the 10 of the Spanish speakers who spoke English as a second language, all of them fell below the 5th percentile. And then here's a whole bunch of folks. See these red dots here? Basically no speech errors. And these were the folks who started learning English at age 4 or 5. And then over here, this individual and this individual, they started learning English at a later date. So they were educated for X amount of years in outside of this country. But the folks over here were educated in the United States. So what's really interesting, I think is really, really interesting about this study, is that we have individuals who had no discernible accent when you look at their speech errors, but yet their speech recognition and noise ability was below normal limits. So the implication is that that early exposure to Spanish has even within the first 4 or 5 years of life, where they're only speaking Spanish, that has a huge influence on their ability to recognize English in noise. Very, very interesting. We're in the process of collecting more data right now and hope to be writing this study up fairly soon. So while 80% of the ESL participants scored below normal limits on the American English hint, the average self-rating for English usage was high. Furthermore, 80% of the ESL participants had speech features that were rated as similar to those for Native American English speakers. Here's a study with one subject, and we're looking at, we're asking the question, or we're looking at 2 ears, and are they better than 1 ear when listening to speech and background noise? So here's a 43-year-old male. We tested him with the hint monoraurally and binaurally under headphones with a simulated sound field environment. Here is his audiogram, and then this gets a little complicated, but hang in there. Here is the speech and noise coming from in front. This is a simulated deafener. So remember, we're simulating the sound field environment under headphones, and we can simulate deafness just by disconnecting the headphone or the earphone right here. So this is simulated left ear deafness. Speech and noise are coming from the front. Here is his score, which is basically on the borderline of normal limits for the noise front test or condition. Recall that's the 5th percentile for the norms. Okay, and now when we simulate deafness on the right side, so this is a monaural left ear test now. This is the score. So very, very similar to the previous score. And then when there's binaural hearing, so both ears are on, we have an improvement. So this is the benefit of 2 ears versus 1 ear when we have the noise front condition. Now let's do the same thing for the noise side condition. So the noise is coming from the left. We're simulating a deafness on the right side. Speech is coming this way. Now remember, we're taking the good ear and blasting it with noise. It's 65 dBA, so it's not extremely loud, but we're playing a lot of noise to the good ear. This is called the unshadowed ear. Remember, in this condition, there's no head shadow effect. And here is the hint score. Really poor. Really poor. So, if the question comes up, well, this child has single-sided deafness. This child is deaf in 1 ear, or this adult is deaf in 1 ear. But the other ear is normal, has normal pure tone threshold, so there's really no deficit. That is actually the impression of a lot of insurance companies. It's the impression of the World Health Organization. If you look at their guidelines as to what's considered a hearing handicap, they say if you have normal pure tone thresholds in 1 ear and you're deaf in the other ear, that's really not a handicap. But look at this. Look at this hearing and noise ability for a person who's deaf on one side when the noise is presented towards the good ear. Very, very poor. Now let's change ears. Same condition. Noise is going towards now the deaf side. We have this thing that's actually working for us called the head shadow effect. So the head is blocking a bunch of this noise in the high frequencies, and when it reaches over here, it's a slightly better signal to noise ratio, at least in the highs, than it would be on this side. And look at the hint score. Predictably, oh, it's much better. Actually, it's quite a bit better. Remember, for every dB change in threshold, that represents a 10% improvement in intelligibility or a 10% change in word recognition ability. So what is that? About 7 dB difference, about 70% improvement in word recognition ability. That's really interesting. Now, what will the hint score be like when both ears are on? What do you think the hint score is going to be like? Is it going to stay here? Is it going to improve a little bit? Is it going to get worse? What do you think? Well, let's take a look. Okay, now with both ears on, oh my gosh, look at this score. See this nice improvement? It's a huge improvement. Another way of thinking of it is we take an ear that's getting not a great signal to noise ratio on this side, and we add to it an ear that's getting a really horrible signal to noise ratio, and when you put those 2 ears together, the brain does this wonderful thing, and we have a huge improvement in speech recognition and noise ability. So you really see the binaural benefit when we look at the condition where speech and noise are spatially separated. Very, very interesting. And we think that this improvement has something to do with central auditory processing. It has something to do with the brain interacting with the sound and utilizing the signals from the left ear and the right ear to get this really nice improvement. Okay, we did the same thing on the other side. You see a similar story. And then we actually did this across several subjects. And this is the unshadowed ear condition. So the noise is going directly to the unshadowed ear. And this is when the noise is going towards the shadowed ear. Or rather, this is when the shadowed ear is listening. This is when the unshadowed ear is listening. And then this is the binaural condition. So we could call this, from here to here, this is the binaural advantage when we reference the shadow ear. This is the binaural advantage when we reference the unshadowed ear. But look at this. Not everybody has this very large binaural advantage. Some subjects have a very small binaural advantage or almost non-existent. So this is very interesting. So what does this have to do with central auditory processing here versus here? Why is this so different? So that's worth a whole set of studies. So on average, this is the binaural score. This is the score for the shadowed ear, and this is the score for the unshadowed ear. Looking at 18 subjects with normal audiograms. So the average binaural advantage referencing the shadowed ear was 3 dB. So 30% improvement in speech recognition ability. And then the average binaural advantage referencing the unshadowed ear was 11 dB. So that's huge. So is single-sided deafness a problem? And the answer is yes. Okay, summary. Speech recognition and noise testing has been shown to reveal aspects of audition not present in the standard pure tone threshold test, also called the audiogram. Binaural testing reveals the effect of head shadow for speech recognition and noise for subjects with simulated single-sided deafness. Here's another question. Is there a relationship between the audiogram and hearing and noise ability? Well, we said there wasn't, right? We showed you all these data. Hopefully you're convinced that you cannot determine speech recognition and noise ability from the audiogram. Well, this is the study that we showed you over here. This one right here. And you see this low correlation coefficient for hearing and noise ability versus pure tone average. Okay, and this is, I'm pretty sure this is the composite score. Now, so that's what Vermilio and Soli found. Now, look over here. Vermilio and Soli also did another study with a smaller group of subjects, and look at that correlation coefficient. Look at that. Oh, great. It's nice and strong. So this would say that there's a relatively strong relationship between speech recognition and noise and the audiogram. This would say there's a relatively weak relationship. What is going on here? What did these guys do? So I'll tell you that it was exactly the same methods. The only difference was the group of subjects. And then when you look across the literature, you find a range from a very poor relationship between the audiogram and speech recognition and noise ability to a very strong relationship. So what is the real story? What is going on here? So what we decided to do was to analyze this, try to figure out why things are the way they are. So is there a relationship between hint and pure tone thresholds? Well, if you look at this earlier study, the one that I showed you previously, no. Look at that R. This is the hint noise composite score. And then over here, look at the R. 0.8, that's a very strong relationship. Look at the data. It's a smaller group, but look at the data. Now, I will tell you that You see these the two subjects out here, their scores right here. That's really improving the correlation when you have data out like that. So let's continue our story. So there's no relationship between the audiogram and the hint here, but there clearly is over here. So I thought maybe there is something. It has something to do with the audibility of the speech and of course the noise. So I took the long-term, or rather the speech-shaped noise. Remember, the spectrum of the noise has the same shape spectrally as the speech signal. So I used the noise, and I took a third octave filter, and I measured the output in dB/SPL, and then converted it to dB/HL. So this represents speech and noise presented at 65 dBA. Okay? And then when the speech is presented at 65 dBA, we would say, and these are the audiograms for a ton of, 215 subjects. So here, the individuals who have thresholds over here, the speech is actually inaudible in the high frequencies. Whereas individuals who have audiograms in this range, where the thresholds are below the level of the speech, they have complete audibility. So we have, you can think of it this way, we have subjects who have partial audibility of the speech, and we have subjects who have complete audibility of the speech, left ear, right ear. So I thought, well, why don't we create two groups? And let's have a group with complete audibility and a group with partial audibility. This is from the study that showed a very poor relationship between pure tone thresholds and the hint. This study showed a strong relationship between pure tone thresholds and hint. But I looked at the groups individually. So the folks with a complete audibility of the hint noise and of the speech signal, 95% of the subjects, look at that correlation coefficient. So is there a relationship between pure tone average and the hint? No. Look at that. It's not significant. It's like zero, right? And then look at the group that had a partial audibility of the speech and the noise. Look at that correlation coefficient of 0.8. 2008 study, complete audibility of the speech and the noise. Correlation coefficient 0.1, about 0.2, not significant. Look at the partial audibility group for the speech and the noise. 18% of the subjects, 0.9. It's almost a 1 correlation coefficient, and it's significant. So then when you add the data, add up all the subjects together, look at the complete audibility group and look at the correlation coefficient, 0.06. There's nothing there. But when it's partial audibility, look at that, 0.9, highly significant. So it really depends on the audibility of the test materials. Again, this is the picture. This is the group of subjects that had complete audibility of the speech and the noise at 65 dBA, no correlation. R equals 0.060. It was not significant. And then look at the correlation coefficient here for this group of subjects between both studies, partial audibility. Look at that nice linear relationship, and it's highly significant. It's a very strong relationship. So can we predict the relationship between, can we predict hearing and noise ability from the audiogram, from pure tone average? And the answer is, it depends on if the subject had complete audibility of the test materials or partial audibility. If the subject has partial audibility, then yes, we can. If they had complete audibility, no, we can't. So if we go back and look at our literature review, let me go back to that. When you look, for example, if you look at this study by Schopp and Zust, what you would see is that they had a high number of subjects that had a profound, I believe they had a profound high-frequency hearing loss. So that's driving that correlation. Okay? And then also the level of the noise has a lot to do with it, which can vary across studies. So it has to do with the subject group. It has to do with the audibility of the speech materials. Okay, so I'm actually working on this paper right now. Okay, so the relationship between hint performance and pure tone thresholds is related to the audibility of the stimulus materials. Hearing in partial noise results are strongly correlated with pure tone thresholds, and hearing in complete noise results are not related to pure tone thresholds. And when I say partial noise, complete noise, I'm also talking about the speech signal. All right, here's the study we didn't do. This is from Dr. Richard Wilson, highly respected scientist and researcher at Mountain Home, Tennessee. He was my boss at the VA hospital in Long Beach. Learned a lot from him and his wonderful department back in the day. And then other authors from the VA system, they looked at the BKB SIN, hint, quick SIN, and WIN test materials on listeners with normal hearing or normal pure tone thresholds and with an elevated pure tone threshold loss. The purpose of the Wilson et al. Study, the purpose of this study was to determine speech recognition in quiet and a noise ability for subjects with normal and elevated pure tone thresholds using 4 commonly available speech and noise protocols. And for the methods, the subjects were tested using the quick SIN, the WIN, the BKB SIN, and the hint speech recognition and noise test. The results showed separation between normal and elevated pure tone threshold groups was least with the BKB SIN and greatest with the quick SIN and the WIN. And actually, this should say was least also with the hint. And so the author's conclusion was that the quick SIN and the WIN materials are more sensitive measures of recognition performance in background noise than are the BKB SIN and hint materials. So this is the WIN, the quick SIN, the BKB SIN, and the hint. And then you could tell that these materials are very different. Speech spectrum noise over here, 4 talk or babble. 4 talk or babble. So if you're listening to somebody speak and there's 4 other people around, that can prove to be challenging. But you know what? It's not as challenging as speech spectrum noise because not everybody's talking at exactly the same moment. So there are moments in time when you have gaps between the background noise talkers talking, and in those gaps you could hear the target speech more easy or easier. Now here is this graph where Dr. Wilson and colleagues makes this, they come to these conclusions. So this is the 5th percentile for speech recognition and noise ability for individuals with normal audiogram. So this is the 5th percentile here for the BKB SIN, 5th percentile for the hint, 5th percentile for the quick SIN, and 5th percentile for the WIN test. And look at the spread in the data. This is kind of hard to see here, but the open circles represents individuals with normal pure tone thresholds, and the squares represent folks with some sort of elevated pure tones. So this would represent individuals with normal audiograms. This would represent individuals with some sort of pure tone threshold loss. And this is the percentage of hearing impaired subjects found in these categories. So for the BKB SIN test, you find 22% of the individuals with elevated pure tone thresholds. We see that they're actually within normal limits for speech recognition and noise for the BKB SIN. Whereas for the hint, you see folks who, 28% of the people with pure tone threshold loss are within the normal limits for the hint test. 10% and 90% for the quick SIN, and then look over here, the words and noise test. Only 1% of the subjects with elevated pure tone thresholds are inside the normal limits for speech recognition and noise with the WIN test, but 99% of the subjects with elevated pure tone thresholds are below normal limits. So this is what Dr. Wilson and colleagues used to say, wow, look at the wind. It's doing such a great job of separating between individuals with normal pure tone thresholds and individuals with elevated pure tone loss. So, but look at the different types of noise. Again, for talk or babble, and look at the levels that he used. He actually used very high, sometimes very high levels of noise. He used 90 dB SPL noise for the hint. Of course, the protocol states that you need to use 65 dBA noise. He used 90, which I never heard of before. But anyway, so he made this conclusion. Let me switch over here. So he reported that the win of the quickstem tests showed the greatest separation between a group of subjects with normal pure tone thresholds and a group with elevated pure tone thresholds. Their conclusion was that the quickstem and wind test are more sensitive measures of speech recognition and noise than the BKB, SIN, and hint. In other words, Dr. Wilson and colleagues used the audiogram as the gold standard for speech recognition and noise ability. Okay, so he said, look at this words and noise test, and look at this relatively strong relationship between hearing and quiet versus hearing and noise. And, excuse me, look at this words and noise test and how well it separates groups of individuals with normal audiograms versus hearing impairment. So essentially he's saying, look, there's a strong relationship between performance on this words and noise test. And there's a strong relationship between that performance and the audiogram. So because of that, we're going to say this is a more sensitive speech recognition and noise test. So this group of researchers used the audiogram as the gold standard for hearing and noise ability, which of course, when you compare that to the studies that we've done, when you compare that to the studies by Dixon back in '46, with Middleweird in '90, an individual with a normal audiogram can have very, very poor speech recognition and noise ability. And you cannot predict speech recognition and noise, at least steady state noise, from the audiogram. So I think Dr. Wilson and colleagues are actually wrong on this issue. Getting back to this quote from Dr. Chuck Berlin in 2012, he said, audiologists generally focus on audiograms because the audiogram has become the gold standard of hearing ability, but the real gold standard may actually be their speech and noise results. And Dr. Berlin, as you may know, has done a lot of work with auditory neuropathy. Recall that one lady in the case studies, young lady who had an auditory neuropathy, and she had this fever-related hearing loss. Remember her? And when her temperature was normal, she had a normal audiogram. Her speech reception thresholds were within normal limits. Her word recognition ability was within normal limits. She had present otoacoustic emissions, but she also had, I think it was an absent ABR. And so that's the classic sign of an auditory neuropathy. She had a normal audiogram. The other speech tests were all within normal limits, but the other speech tests were presented in quiet. And then when you look at the hint data, she had extremely poor hearing and noise results. So if we just use the audiogram as our guide for what the gold standard of hearing ability is, then we'd say from the audiogram that young lady should have very, very good hearing. But when you look at her hearing and noise test results, then that's when you see the deficit. So I believe that's why Dr. Berlin, who's done a lot of work with auditory neuropathy, came to this conclusion that the real gold standard may actually be our patient's speech recognition and noise results. And that concludes our lecture on the second half of research using the hint.